In this video, we are going to solve some mixture problems. These problems involve mixing together two things with known and unknown quantities, resulting to a mixture also with known and unknown quantities, and our task is to find or solve for those unknown quantities using a component balance. Let's take, for instance, two alcohol solutions. An alcohol solution, by the way, is a mixture of water and alcohol, pure alcohol if you will. So let's call the first alcohol solution as A and the second alcohol solution as B. If the amount of alcohol solution A is X liters and the amount of alcohol solution B is Y liters, adding the two solutions will result to a mixture containing a total of X plus Y liters, right? Let's call this mixture as alcohol solution C. Now let's say A contains A% alcohol, B contains B% alcohol, and C contains C% alcohol. Since alcohol solution C is obtained by mixing or adding alcohol solution A and alcohol solution B, therefore, the total amount of alcohol in C is equal to the amount of alcohol from A and from B. So let's make a component balance, in this case, an alcohol balance. The amount of alcohol from A is A% times the total amount of A, so X liters. That would be A% times X plus the total amount of alcohol in B, that's B% times Y liters, so B% times Y, and this should be equal to the total amount of alcohol in C. So the total amount of alcohol in C is C% times X plus Y liters. This is now our component balance. So let's solve some problems. Problem number 1. How many gallons of milk containing 5% butterfat? This means that it's a 5% milk mixture. Okay, must be mixed with 90 gallons of 1% milk mixture to obtain 2% milk mixture. So we can start by making an illustration just like what we did earlier, or we can make a table to summarize the known and unknown quantities in the problem. This time, let's use a table. Let's identify first the milk mixtures that we want to mix. We have the 5% milk mixture and then the 1% milk mixture. If we add these two mixtures, the result should be a 2% milk mixture. Next, let's determine the amount of the individual mixtures. So for the first one, the 5% milk mixture that contains 5% butterfat, its amount is unknown, so we can call it X. For the 1% milk mixture, we have 90 gallons, so the total should be X plus 90. Okay. Next, percent fat for each of the mixtures. 5%, of course, 5, 1%, and then the resulting mixture should contain 2% fat. Lastly, let's determine the amount of fat for each of the milk mixtures. So for the first one, the amount of fat is 5% times x gallons, so that would be 0.05x. Second, it contains 1% fat, so 1% times 90 gallons, that's 0.01 times 90. The sum of these two should be 2% of x plus 90, so that's 0.02x plus 90. And we are asked how many gallons of the 5% milk mixture should we add to the 90 gallons of 1% milk mixture, so that would be x. Okay, so let's set up the component balance for this particular problem, fat balance. Okay, so the amount of fat from the first milk mixture is this one, 0.05x. The amount of fat from the second milk mixture, this one, so plus 0.01 times 90 equals the amount of fat from the resulting mixture is this one, so 0.02 x plus 90. Okay, and then we solve for x. We can convert the decimals to fractions. So let's say for the first term we have 5 over 100 x. 0.01 is equivalent to 1 over 100, so times 90. 0.02 is 2 over 100, and then x plus 90. So to eliminate the fraction, multiply both sides of the equation by 100. The result is 5x plus 90 equal to 2 times x plus 90. Let's distribute 2. So 5x plus 90 equal to 2x plus 180. Then combine all the x terms or the variable terms on one side and the constant terms on the other side. So 5x minus 2x, that's 3x. 180 minus 90, that's 90. So 90 divided by 3, we get x equals 30, and the unit is gallons. Second problem, a food chemist wants to mix some tropical sensation which contains 10% juice with some Very Good which contains 20% juice to obtain 10 gallons of a new drink that will contain 14% juice. The question is how many gallons of each should be used. Again, let's summarize using a table. So we have the juice mixtures, the tropical sensation and Very Good. And then if we add these two mixtures, let's call the resulting mixture as the new mixture. Next, the amount of the individual mixtures. So first, the amount of tropical sensation. It's unknown, so we can call it x. The amount of Very Good is also unknown, but we know the total mixture. The total mixture is 10 gallons. If tropical sensation is x, therefore Very Good is 10 minus x. Again, because the total is 10 gallons. So percent juice, 10% for tropical sensation, 20% for Very Good, and the new mixture should contain 14% juice. Now let's determine the amount of juice. So for the tropical sensation, the amount is 10% times x, so 0.1x. For very good, the amount is 20% times 10 minus x, or that's 0.2 times 10 minus x, and the resulting mixture, or the new mixture, should contain 14% juice. Therefore, the amount of juice is 14% times 10 gallons, so 0.14 times 10. We are asked to find how many gallons of tropical sensation and very good. So x and 10 minus x. Now let's set up the component balance based on the last column. Okay. So for this problem, we are going to make a juice balance. Alright. The amount of juice from tropical sensation is 0.1x. Add this to the amount of juice from very good, 0.2, 10 minus x. The result should be 0.14 times 10. Then we solve for x. 0.1 is 1 over 10 times x plus 0.2. 0.2 is 2 over 10 times 10 minus x equals 0.14 times 10, that's 1.4. 1.4 is 14 over 10. So we can multiply both sides by 10. The result is x plus 2 times 10 minus x equals 14. We now have x plus 20 minus 2x equals 14. Okay, so let's combine like terms. We get 20 minus x equals 14. Therefore, x is equal to 20 minus 14, that's 6. This is the amount of tropical sensation, x gallons. And then very good is 10 minus x, so that's 10 minus 6. So the amount of very good is 4 gallons. Problem number 3. Aaron mixes 12 pounds of dried apricots that sell for $5 per pound with some dried cherries that sell for $8 per pound. If he wants the mix to be worth $7 per pound, then how many pounds of cherries should he use? This is a bit different from what we've solved so far, but still we can use the concept of the component balance to solve the problem. Okay, so let's make a table. We have the fruits, apricots and cherries, and then Aaron wants to have a mix of these two fruits. Next, let's determine the amount in pounds. So apricots, we have 12 pounds. The amount of cherries is unknown, so we can call it x. Therefore, the total amount in pounds is 12 plus x, right? Next, we have the price per pound. Apricots sell for $5 per pound. Cherries sell for $8 per pound. And the resulting mixture of the two fruits should be $7 per pound. So this is telling us to make a price balance. Therefore, the next column is for the total price. Okay. Again, apricots sell for $5 per pound, and we have 12 pounds of apricots. So the total price is 5 times 12. Same goes for the cherries. total price is 8 times x, and then for the mixture, 7 times 12 plus x. We are asked to find how many pounds of cherries, so that would be x. Let's make a price balance. Total price for the apricots, we have 5 times 12. Total price for the cherries, 8x. And then total for the mix is 7 times 12 plus x. Okay, then we solve for x. This is 60 plus 8x equals 7 times 12, that's 84, plus 7x. So 8x minus 7x, that's x. 84 minus 60, that's 24. So this is now the amount in pounds of cherries that we should use.